All right, it's being recorded. All right, so we have here the voltage being equal to some peak voltage sine theta, right?
There is nothing on the screen, Master.
Me?
There is nothing on the screen.
I don't know what's happening here. Let me. How did it stop sharing here? Let me get this back on. Are you seeing it now? I hope you should be seeing it.
Yes, sir.
All right. So, based on what the question, the information that the question gives us, we can reason that the generalized expression here for our sinusoidal input, any instance in time, will just be the peak voltage sine theta, right? And here you can now just substitute, right? You know that the peak is 100, right? So we have, when this is 100 at peak 200 sine theta, we can work out what theta is equal to. Sine inverse of 0.5, right? So that's this is our alpha basically, right? Right. So that's what sine inverse of a half is. What, 30 degrees? Right. So that's 30 degrees. Or in radians, we say that's pi by 6 radians. All right. So we have worked out our firing angle. Now, what is the conduction angle? Right. So this is 1. So conduction angle, if you recall, let me just give a little sketch right here. So that's your input. And let's say you trigger this SCR with some pulse, and your output somewhere here. All right, so this is your VP. So this is the VP sine theta. So right here, this is your alpha, right? So that's your firing angle. However, conduction angle is defined in that space, right? What is this angle? Let's call this phi, conduction angle. So what is the conduction angle if your firing angle is 30 degrees? Hello?
Yes, sir. Yeah.
All right. So remember, we look at this over one cycle. So if here is alpha, what's the rest? The rest of it is defined as your conduction angle, right, within that period, right? So this would be pi by 2 sorry, pi. This would be pi right here would be your pi, and this would be 2 pi. So what would be this angle here? It's just pi minus alpha, right? Your conduction angle will just be equal to pi minus alpha. And that's just, you can substitute, right? So that's pi minus, and your alpha here is pi by 6. Right, so that's equal to your 5 over 6 pi, or that's just equal to 150 degrees. And the last part, what's the average current? What's the average current? Right, you'll need to find out what the average voltage is. I will say that's the peak divided by 2 pi. That's into 1 plus cosine alpha. So you can make the substitutions here. Your peak here, we have it as 200 over 2 pi, 1 plus cosine alpha. Alpha here is 30 degrees. So you can work that out. Tell me what you get. What's the answer for that? Cosine 30, that's root 3 over 2. Root 3 over 2 plus
59.4.
So that's 59.4 volts. All right. So we want the average current here. So the average current, right, that's the average voltage that we found. But you're told that you have a load, 100 ohm, right? So the current that will be flowing here, you can see I average is going to be equal to the average voltage divided by that load, right? So when we make that substitution, you should get 0.4 divided by that 100. So that's equal to 0.594 amperes. All right, so you can try this one. All right, so we made use of this formula here. So you can try this one. When you're done, just let me know the answer you get, right? So an SCR half-wave rectifier has a forward breakdown voltage of 150 volts and a gate current of 1 milliampere flows in the gate circuit. If a sinusoidal voltage of 400 volts peak is applied, start to find the firing angle. Find the average output voltage, the average current for a load of 200 ohms, and the power output. And here you're asked to assume that the gate current is 1 milliampere and throughout, and that the forward breakdown voltage is more than 400 volts, and that's when Ig is equal to 1 milliampere. Again, the first part of it is somewhat similar to what I showed you earlier on, where you have the information as relates to the peak voltage and the output voltage in this instance. So you can use this to determine the firing angle. Very simple. What do you get for your firing angle?
So is it 22?
That's correct, 22, right? 22 degrees, right? So this is very simple, right? Again, you're just using the formula, right? The voltage V peak sine theta, right? So therefore your theta is the sine inverse of your voltage. They are told here that the output voltage here is what is it, 150. So that's over 400, right? And this should give you 22 degrees, right? So this is your alpha. So therefore your alpha, the firing angle is 22 degrees. So your average output voltage, very much similar, you know that your output voltage, the peak over 2 pi to 1 plus cosine alpha. Can be your substitution here. The peak, that's 400 over 2 pi to 1 plus cosine 22. Right, and you can tell me what you get. So your average load current. Say that again.
122.69.
All right, so 122.6. This 122.69 volts. Therefore, your average voltage here will be V out, average output divided by our load. So 122.69 divided by your load here. I told it's 200, right? So that's equal to, you can tell me?
0.61.
So that's 0.61 ampere. And the next question asks for your power output. Right, so your power output here, your average power, that's the average power output. Right, so the average voltage times the average current, right? That's what it's going to be in this instance. So 122.69 times 0.61, right? And we should get your average.
75.26.
75.2.
26, yeah.
Watt. All right, very good. All right, so we can move to our next question here. So the full wave control bridge rectifier shown this will be shown below as an AC input of 120 volts, and that's RMS at 60 hertz, and a 20 ohm resistor. Right, the delay angle is 40 degrees. You're asked to determine, so that's the circuit. Right, so you see it's a full wave, full bridge. So what's the average current? How do you find the average current in this?
You have to find the firing angle first.
Huh?
You have to find the firing angle first.
But you're told what the firing angle is. You're told that it is 40 degrees.
Oh.
Sir, there's a chat in there. Since our V is a full wave, right? So that assumes that the VO is going to be twice that of the half wave. So with VO 2VO over the resistance, give her the current.
2VO?
Yes, sir.
How you get that?
Just by looking at it, it's a full wave. So we just assume that the half wave, the full wave would be twice the half wave formula.
Oh, all right. We can look at it. We can look and see. All right. So for this one, what's the formula?
So,
Yeah, you see, you know, the output, as you're saying, so it would
VP
be the V. Oh, sorry, let me get that off. VP over
pi.
pi into 1 plus cosine alpha, right?
Yes, sir.
Right. So you can substitute your values in it.
Right.
But remember, here you have 120 volts, and that's RMS. So you need to get this to peak, right? So that would be what, root 2,
Root 2. Yes, sir.
right? And times 120 where your pi 1 plus that would be cosine 40 degrees, right? And this is going to make it equal to 95. I don't remember what, I think it was 95, something like that. You can check. Huh?
I'm writing it in the calculator. Hold on.
I'm not sure that is right.
It's 95, sir.
All right. So I can write back 95. All right. So that's the first part of the question. Was the power absorbed by the load?
Right, so sorry, that's
sorry.
the
We didn't find the current. Oh, the average current. So what would that would be simple, right?
yes,
So
sir.
your average current here, that's just the average output voltage divided by your load resistance here. Right?
Yeah.
So that would be 95 divided by 20. What do you get?
4.775.
4.77
Yes, sir.
amperes. All right, so now we're finished with part 1. Right, so we can go to part 2 here. Right, so the power absorbed by the load, remember, here, here, I don't want the average power, right? That is not the average power, right? Before it was the average power.
I want RMS.
Right, very good. So how do we find the RMS here?
Hold on.
Times
The
the
time to pi.
Huh?
Is it VO times pi divided by root 2 for the RMS?
No, it couldn't be that. This is where a lot of people make error. Remember, you have to pay attention to the waveform, right? So what would be, you need to find the, let's say, out of the RMS, the RMS voltage, output voltage that is, or the RMS current, right? So by squaring the RMS current, you multiply by the resistance. So that would have to be the strategy here.
Square the RMS.
Oh, sorry. Right. So how do you, what's the formula you use to get your RMS current? or your voltage here.
Divide the voltage by
No, it's in your worksheet. Sorry, not worksheet. Your lesson number 3, right? You don't remember the formula?
Hold on.
Right. So in lesson number 3, that's where you would find that information. Right, and study the full bridge.
So we did full bridge.
Yes.
I think I was.
You have forgotten it.
I
So
think I was. Yeah.
your output voltage is going to be, let's say, right. So I want the RMS. The output. You should look back at your notes. Output RMS, right, is going to be equal to Vm. I can put, or let's say V peak half minus alpha over 2 pi plus sine. This would be what I think 2 alpha over 4 pi.
Sorry, can you upload it? I missed that class.
No, yeah, it's there.
I think the link is missing, sir.
Huh? Lesson 3.
Yeah, I think the link is missing.
Link isn't. That's strange. Let me check it. Lesson 3.
Because the class that I missed, I couldn't find it on there.
Okay. Lesson number 3. All right. Lesson 1, lesson 2, lesson 3. Yes, lesson 3 is there.
And there's a video behind. I think the link is there, but the video isn't there when I click the link, sir. For one of them.
Huh? Oh, lesson 3. The PowerPoint is there. Let me see. Yes. See, I'm opening it here. You mean there's a video that's missing for one? As I'm able to access lesson 3. All right, let me tell me which one and I'll try to fix it, but let me just finish this before where am I? Right here. Nope. Trying to find this one. Oh my, sorry, I pressed the whiteboard here. Let me stop this whiteboard. I think I pressed something. I press something. Yes, Gareth, MJ. I think it's about time. All right, let me just wrap this up before we leave. I think I accidentally did something a short while ago. All right, let me bring back this up. All right, so we're here, right? So Conrad, you tell me which link is not there, is broken, and I'll try to fix it. All right, so the RMS, so we have to calculate this. So you'll have to make the substitutions here. And I can tell you from now, it's better you work with radians, right? So put your calculator in radian mode when you're using this formula. Otherwise, it will not work. So please get accustomed to doing this. So put your calculators in radian mode. Right.
Yeah,
So
for part one,
right.
for part one, why you wouldn't put it in radian for part one?
No, we can leave it like that. But for this formula, right, so we can, IRMS therefore would be the peak, take the peak, divide it by the value resistor that we have there. Right? R, load, right? So put the half minus alpha over 2 pi plus 2 alpha over 4 pi. All right, so we substitute now. Right, so the peak here, that would be the root 2 times 120. Let me, I think I may need a bit more space. And we divide here by 20. And this is a half. And when we convert this to radians, it should be, let me just do that, 0.698, is that correct? 0.698 for 2 alpha plus sine, and multiply that by 2. Right, so 2 times this, you can work that out, times 0.698 divided by 4 pi. When that is done, you should get something like 5.8. You can check if what I did is correct. So now to get the power, you just need to multiply the square of this RMS current by the load resistance, and that's the power. All right, so to get the power, let me just do that over here. So your power is just I square RMS times the resistance, and that's 5.8 if it is correct. Square multiplied by 20, and this is 673 watts. Now, the last part asks you for the source volt amperes. That's pretty much simple. Just multiply the RMS voltage and the current, right? So for part 3, the source volt ampere, that's just VRMS and the IRMS. And so that's just equal to 120 times 5.8, and that should be about 696 VA. And the next question, the power factor. Power factor, that's just the ratio of your real power to your apparent power, right? Let's use S since we start with S. The real power to your apparent power, right? So we got 6, what was it, 672? Right, 672 here, right? $696, and that's correct. That should be about 0.967. All right, so that's how we do that one. All right, clear? But I think you need to try this on your own. This part often cause all kinds of confusion. All right, now this question, are you still here? I know it's time for you to go. You have time to work. Huh?
Still here, sir.
All right, do we have time to work another question? All right. All right, so the other question is this one. Last time I told you to take your calculator and you will do some calculations around this, a definite integral. But as the time has passed, we can always look at this. When is your test? Next week or the week after?
Next week.
Next week?
Yes, sir.
27th.
Oh, your test
Sir.
is yes.
Sir.
Yes.
Hello?
Yeah, I'm here.
Hello? Sir.
Yes. Are you hearing me?
Yes, sir. Some of us have industrial electronics as well. Would it be possible to push that back as well? Okay. So
No,
you would remember industrial electronics thing.
Remember next week it's a public holiday, so I pushed back the power electronics to the other week.
Yeah.
So you're is it that you're asking me to push the power electronics to the other week as well? But I don't think the Tuesday is on holiday.
Yes, sir. Yes, sir.
It's on holiday?
No. But no, sir. In effect, we'd have both of them in the same week. So I don't know if
No, it wouldn't be in the same
some
week.
leniency where that is concerned.
No. If you do power electronics test
Yes, sir.
next week.
Because No,
Next week Tuesday is not an holiday, right? So the Monday would have been industrial election. I think Monday is on holiday. Is it? I'm not sure.
no, sir.
Sir,
We have it for
Monday's
the
Thursday.
we have it for the following week.
Monday's a holiday.
It's
The
Monday.
holiday. Right,
Yeah?
right.
Yes, sir.
But we have it for the we have power electronics for the 27th.
Okay.
Monday is a holiday, sir.
So your power electronics test
Understand?
is
So,
not next week. It's
The week
27th.
of the 26th. No, we have both of them that week, which is the 26th and the 27th.
Yeah.
Oh, so
So
it
that-
was next week. It was 27.
Right.
Oh,
Right.
So we're
Remember,
wondering
you're wondering if what? What do you want it to come to the 20th?
So I was wondering if the electronics, no, to be pushed back the power electronics. Would be the week after the 27th.
The week after the 27th. If everybody agree, I have no problem. I could do that. So
No,
we
sir,
have
we'll
time.
sir. I can, if it's pushed back, sir, I will be busy, sir, after the 27th.
All right. So we have an opposition there. All right. So
so what
seems
about
like next week. If you want it next week, that's all right.
Even better.
How about next week? You can raise your hand.
So
If
it's
everybody, you can raise your hand if you want it next week.
Hello?
Yes. I see 2 persons or 3.
Sir?
1, 2, 3, 4. 4 persons. All right. All right. Wait, some persons. We only have 8 persons here. All right. How many want to keep it on the 27th? So you can lower your hand so that those on the 27th can raise. 27th? Only 1 person. Oh. Right. After 27th, so that would be November 3. How many say November 3? Only 1 person.
I'm going to have a problem after the 27.
Right. So it seems like your test should be next week Monday.
Tuesday.
Sorry, next week Tuesday. I'm sorry. Next week Tuesday. All right. So prepare for your test next week Tuesday, and the following week, those of you who industrial electronics, and you'll have your test that time. All right. So.
Okay, sir.
All right. So until we meet again, you take care.
Sure, what's the topic? This topic is coming on these calculations.
Yes, everything that we have done up to this class, that's what is going to be done here. Oh, I didn't remember to stop